Here we are for video 2 of section 5.1, and we're continuing with our drawing of graphs. We have one more example and then we get into something a little bit different. So example number 7, f of x equals -2 times x plus 3, the quantity raised to the 5th power, plus 3. So I know x to the 5th is the parent function. This plus 3 right here tells me I need to go 3 to the left. This plus 3 here means I need to go 3 up. The negative says I need to reflect over the x-axis. And the 2 right here says I need to stretch the y values by 2. And so, first thing I'm going to do is actually deal with the transformations. I want to go 3 left and 3 up. And so this is going to become my new turning point, so to speak. There's not really a vertex on x to the 5th, but it is the point where it all shifts, so to speak. So there's going to be our new set, and we know it's going to look either something like this, come down like this, or it might look like this, depending on what happens. Well, the reflection over the x-axis basically means since it was normally x to the 5th looks like this, reflecting over the x-axis means it's going to look something like this. And then finally, stretching by 2, well, instead of 1, it will be 1, 2, so I would have to come up to about here. And instead of -1, I have to go -1, -2, which is about right there. And then 2 normally is, whoops, I forgot to reflect over the x-axis, didn't I? So this one has to come down here, and this one should be up here. So let me get rid of those bad ones there. And then 2 away from the midpoint, or the middle point there, on 5th power is already to 32, and when we stretch it by 2, that's 64. So that is way out of line. So what we get is we're going to get this that appears very much like an x cubed, but if an x cubed would be put here, x cubed would actually come out here and look more like this. It would be fatter than this one. X cubed would come along and look something similar to that. Now the next examples, it says form a polynomial whose zeros and degree are given. So the first thing, when we're given the zeros, we actually want to put them into their factors. So a 0 of -1 means it would be x plus 1. A factor of 1 would be x minus 1. Notice the factors are always, compared to the zeros, are x minus the zeros. And then finally, if a 0 is -6, it will be x plus 6. Now we also need it to be degree 3. Well, I've got degree 1, 2, 3. There's my 3 degrees, so all I have to do is multiply this together. Multiplying x plus 1 times x minus 1, well, that's a difference of squares. So this is x squared minus 1. Then multiply that by x plus 6, and then I have to FOIL it again, and I get x cubed plus, taking the outer ones are 6x squared, the inner ones minus x, and the last ones is minus 6. And so the answer would be x cubed plus 6x squared minus x minus 6. Number 9 gives us 4 zeros and degree 4, which is really nice because it will end up being, we don't need to do anything extra. So the first 0 is -5. That means my factor is x plus 5. -4 would be x plus 4. 1 would be x minus 1, and 2 would be x minus 2. Now what I'm going to do is I'm actually going to FOIL these two together, and get a trinomial, FOIL those two together and get a trinomial, and then we have to do long multiplication to get the final answer. Now realize long multiplication, you just have to take each of the terms times each of the other terms and you will get the correct answer. So if we FOIL this out, we get x squared plus 9x plus 20. FOIL these two out, we get x squared minus 3x plus 2. And now we're going to take the x squared times everything here, the 9x times everything here, and the 20 times everything here. Combine any like terms and we'll end up. But realize what we end up with is x to the 4th plus 6x cubed minus 5x squared minus 42x plus 40. And that is taking x squared times this, times this, times this. 9x times this, this, and this. And 20 times this, this, and this. Next group of problems. For the polynomial, list each real zero and its multiplicity. Now multiplicity is basically asking, what, how many of the roots or how many of the zeros does this account for? And it's just really a matter of looking at the exponent for each one. So let's look at number 10. Number 10, f of x equals 5 times x squared plus 3 and x plus 2, the quantity squared. Okay, realize what, in essence, since we're trying to find each zero, we're going to set each one of these factors equal to 0. Well, 5 equals 0 doesn't make any sense. It can't happen anyway. So then we're going to let x squared plus 3 equal 0. And let's see what happens here. Solving for x, subtract 3 from both sides. And when we attempt to take the square root of both sides, we realize we can't take the square root of a negative. So there's absolutely no zeros that will be involved for this portion. However, we can take x plus 2 and set it equal to 0. And subtract 2 from both sides so that x equals negative 2. Now we did actually find x equals negative 2. Now we need to look at multiplicity. If this had multiplicity, this would actually have multiplicity of 1. It's a little bit of a bizarre situation. We'll look at this a little bit later. But realize what's going on with this x plus 2. We know the answer is negative 2, or that's where it will equal 0. But it has a multiplicity. It has a multiplicity of 2 because of that exponent right there. Now, what this tells us is anytime we have multiplicity of 2, then that means the graph right at x equals negative 2 will not cross the x-axis. Instead, all it will do is touch it and bounce back. Whether it was coming down, it will come down, touch the x-axis and bounce right back up, or if it was coming up to hit the x-axis, it would go up, hit it, and then bounce right back at the bottom. So that means since the multiplicity is 2, it just touches. Once you determine the multiplicity, whether it touches or whether it crosses is very, very simple. And here's how it is. Multiplicity, if it's even multiplicity, then it touches. If it's odd multiplicity, then it crosses. And that's all you need to remember. Even multiplicity touches. Odd multiplicity crosses. So let's look at number 11. Number 11 is f of x equals 1/2 x to the 4th times x squared minus 5. Okay, first thing, since we want to find the zeros, we are going to set each of these factors equal to 0. 1/2 equal to 0 doesn't make any sense. X to the 4th equals 0, we'll just take the fourth root of both sides. And technically this is plus or minus because we're taking an even root, so it'd be plus or minus 0, but that doesn't mean anything either, or that doesn't make any sense either. So x equals 0. But since it was being taken to the fourth power, that means multiplicity here is 4. And just as I previously mentioned, since multiplicity is even, then that means it touches and then just goes right back. It touches the x-axis and then goes immediately away from it. Likewise, we need to let x squared minus 5 equal 0. Add 5 to both sides so that x squared equals 5. Take the square root of both sides, and so x will equal plus or minus 5. Now here's where many people will say, well, I see the 2 here, and so this is multiplicity of 2. But when we calculated it, we think, okay, yeah, there should be 2 answers to this, and look what we have. We have both positive root 5 and negative root 5. So each one of these would represent a multiplicity of 1. Both the positive root 5 is multiplicity 1, and negative root 5 is multiplicity of 1. And so as a result, what this does is it crosses the x-axis and continues in its general direction.